Okay, so this is saying if we're given side A, side B, and gamma, we can find the area. Side A is down here, side B would be this one, and gamma is here. So if those are the only pieces we know, we can find the area. Typically, old school, if we did not know this formula, we've never seen it before, we could find the area of a triangle. How? What is the old school area of a triangle formula? 1/2 base times height. So 1/2 base times height. Well, our base here, we actually have that as our side A, but the height is looking at this right here, right? It's straight down vertical that makes a right triangle. Yes? If I wanted to find this height here, we could use law of sines, because we know that h over sine of gamma, they're related. So if we know gamma, is the same thing as that side B over our right angle here, right? Sine of 90. What is sine of 90 degrees? 1. So h over sine of gamma equals b times 1, or b divided by 1. So if I get h by itself, right? That side times sine of that angle, yes? Here we have that. H. It's coming from the law of sines and the fact that I set this up with A on the bottom. Okay, so this comes from our law of sines and things like that. We'll also have times when we can use our law of cosines to find the pieces we need. But this is coming from those pieces. So if we have a side angle side and we want to find our area, I could do this part of it and figure out this height so that we could do 1/2 base times height. This does the same thing. So if you don't want to have to memorize this, it's totally fine. We can do it. But it is going to be it's not awful. It's not awful. Okay, so we're going to find several areas today. Several. Okay, but this formula, our 1/2 AB sine of gamma, notice how this is a side, and the angle between, side, angle, side. Not side, angle, side. Then we can use this formula here. Okay, so I'm going to give us some side, angle, side situations, and we're going to find the area. Boop. So this is literally the same triangle I had up here. It was just kind of copy and paste. I've got our area formula up here. We're given gamma of 143. Side A is 7 meters. Side B is 18 meters. So the first thing I'm going to do is label stuff. Angle gamma, that's this guy here at point C, they're telling us is 143 degrees. It does not matter if it is to scale or not, because we're looking at the relationships. So yes, that is an acute angle, and 143 should definitely be obtuse. The policy still holds. Our side A, opposite angle A, that's our 7 meters down here. And our side B, which is opposite angle B, that's our 18 meters here. So again, I could go through, I could find my height, we could do our law of sines to find all those pieces. Using this is going to be easier as long as we have two sides and the angle between. So our area is 1/2 times each of these sides. Oh, sorry, I didn't have these the same color. So we're going to have our 7, our 18, and our sine of gamma. And then we're going to type that whole thing in the calculator. Because we're finding this piece gives us that height, and this is 1/2 our base times the height. What do we get as the number here? 37.9.91.914. We will tell you where to round when it comes to questions. And then our unit here, we've got meters squared. Because this is a unit in meters, and this is a distance, this is a height. So that is also a meter. So meters times meters gives us meters squared. That's the end of that. Okay. This is our answer. Questions on this one? Okay. Yeah, we get a little scared when we start seeing new formulas, but I promise these ones aren't awful. So, in triangle PIG, for some reason, it's triangle PIG, triangle pig. I don't know why Google has decided I'm not allowed to put the symbol for triangle in. So, whatevs. But in triangle PIG, we've got the measure of angle I is 40 degrees, the measure of angles G is 81 degrees, I is 4 inches, G is 12 inches, and we're asked to find the area. When we have something like this, draw it. A triangle. It does not have to be perfect. Do not bust out protractors or anything. We are just rocking out. Okay. What's up?
I was like, the last time we used a protractor.
Yeah, I was gonna say we're not trying to draw anything to scale. We're getting the relationships. We don't care about scale. Like honestly, I don't know that I could put my hand on enough protractors for us to measure stuff like that. So it doesn't matter which points we call which. I'm just gonna go PIG like this, so it still looks like pig, because it's cute. Pigs are cute but scary. And we're gonna label stuff. So our measure at angle I, that's 40 degrees. So this guy's 40 degrees. Our measure for angle at G is 81 degrees. So that's this guy over here. We get that our side I is 4. So that's this guy across the way over here. And that our side G is 12 inches. This guy. We are trying to find our area. What do we need to do? Yeah, let's figure out what's happening at angle P, because in order for us to use that area formula, we need to have side, angle, side. And I have pretty much all of the other information. So to figure out what the measurement at angle P is, I'm trying to find a color I haven't used yet. We'll do orange. So our measurement at angle P is going to be our 180 minus the 40 minus the 81. So what is the measurement at angle P? 59 degrees. So now I know that this angle is our 59 degrees. And we can use our area formula because now I have a side, angle, side. So we've got our two little legs and our angle between them. So our area formula we have our 1/2. We good. Our side, what are we praying for now? Our side, I said, what are we praying for?
Wait, what?
Sine of, oh, nothing. I'm just commenting on something else happening in class. Sine of our 59 degrees. It needs to be our side, and the angle between. So we have to have a side angle side for us to use this area formula. We need side angle side, so we need these three pieces. I can't use either of the given angles because I don't know side P. And before we didn't have enough information to get the side length for P. Now that I have this, I could use my law of sines, find that side, and then I could use whatever angle we wanted. We don't need to though. We can go with this. And we can type this sucker in the calculator. And I was gonna say, I don't have the answer because I had a typo in my book before, so I'm just doing it again just so I can double check.
How much are we running to? Just this?
Yeah, we can do tenths. That's fine with me. Yeah, we're gonna have our 20.6. Our area is 20.6. What unit? Inches squared. We are in an area. It's always going to be a squared unit. Okay? So if we are given side angle side, or if we're given enough information that we can find out the angles, we can use that. We are going to have another angle formula for when we don't have an angle. Because sometimes we don't. Sometimes, it's like with our law of cosine stuff, we were given side, that kind of thing. So at that point, I don't have enough information to find an area because we don't have any angles. Again, I'm going to say, imagine being bored enough to figure this out. Don't freak out. Somebody named Heron figured out how to find the area when all we have is side lengths. Side. A, B, and C are the sides of our triangle. A, B, and C are the sides of the triangle. What S is called the semi-perimeter. Seriously, it's add up all the sides, divide by 2. It's the half of the perimeter. Again, thus be grateful for the advent of the internet. Imagine being this bored. To be fair, it's not difficult to use. Once we get the hang, like, herons is better than angle sums and differences. What's that? What's up?
Yes.
Yes. We cannot go and get revenge on Heron. No vengeance. I was gonna say, I think we do actually have a little blurb in here. I might be able to figure out when. Let me see. If not, I know I have it in one of my grad school books, and I can look it up when you get it. But I don't. We don't really need to know. Okay, so write this down. Oh, they didn't give us a little blurb about him. Usually they do. I don't know. I'd have to Google him. I'm not gonna right now. Okay, so to find our semi-perimeter, all we do is add up all of our sides and divide by 2. That's what the S is. So that's the piece we're gonna find first. All of these pieces are, bless you, is the difference between this S and each of the sides. So we're gonna have S times the difference between these. All of these are multiplied together. So we're gonna try this. I'm gonna give us 3 sides. So we don't even need to draw the triangle. You can if you want to, but you don't need to. The first thing we need to figure out is we need to figure out our semi-perimeter, that S. So we're gonna add up all the sides, divide by 2. 14 plus 21 plus 27. So our three sides are our 14 centimeters, 21 centimeters, and 27 centimeters. So our S, this semi-perimeter, I'm going to add them all up. 14 plus 21 plus 27, and divide it by 2. So what is S? Should not be 48. 31. So S is 31. Then I can use my herons formula, which I'm going to write the whole thing up here. That's when we have our S times our S minus A, S minus B, S minus C. So now I know S. So our area is going to be that 31 times the difference between 31 and each of these sides. I don't know why I didn't circle centimeters on that one when I did for all the others. So we're going to have our 31. You're a couple steps ahead of me, but yes. Okay, you're a couple steps ahead of me, but yes. And we're going to take our 31 minus the 21. And we're going to take the 31 minus the 27. I do recommend writing it out and doing a little bit of simplifying before I just plug in the calculator, because when it's this long, it is really easy to mistype one thing, and that'll throw the whole thing way off. Especially since this is mostly subtraction. We can do subtraction. We really can. Because we have 31 times, what's 31 minus 14? 17. You were one ahead of me. 31 minus 21, 10. 31 minus 27, 4. 31 times 17 times 10 times 4. You could do that as well. You could simplify it there. Or we can type in the square root of 31 times 17 times 10 times 4. What do we get as our area? 145.19 or 0.2 or 0.189. What unit? Centimeters squared. Okay. So the S part is weird, but other than that, the calculation is not super duper complicated. Okay. Questions on this one? Do another one very much like it. Boop. Mr. B has a triangular goat pen. Maybe it's Mr. Bean. Random choice, but okay. And the sides of the pen are 23 feet, 19 feet, and 27 feet. So we are asked to find the area. So first thing we need to know is that semi-perimeter. What is S gonna be? Double checking because I've had problems with it before. No burger.
34.5.
Yes. Good say. 34.5 is that S. So when we're setting up herons, that's the first thing we need, because herons, we need our square root, and then we find our difference of that 34.5 with each of the sides. So we're going to have our 34.5 minus our 23. Who's judging? 34.5 and the 19, and then our 34.5 and the 27. I know you guys are probably way ahead of me, but I'm just trying to write everything down. what do we get? I was gonna say, I heard a lot of different overlapping versions of 214.76 feet squared.
I literally did. Oh my.
Again, I will make sure on quizzes and tests that we specify where to round. Okay. We'll do one more like this. No. Because I want to do one like one of the hard ones on the homework. Okay? Because there's a challenging question on the homework that I want to do one like it, so I have one very much like it. Okay, but I want to do one more with our area stuff because they will sometimes give it to us slightly harder than just listing out all three sides. This is 8.2. Correct. Boop. What's going on? Are you okay? The math? Oh, no. No. We're not giving that up. Gotta keep that part. Gotta keep that part. All right. So we're asked to find the area of an equilateral triangle that has a perimeter of 21.3. That's equilateral means I know that every single one of my sides, A, B, and C, are all going to be worth what? The same amount, which is going to be what? How do we get the 7.1? The 21.3 divided by our three equal sides. So all three sides are going to be 7.1 feet, right? Yes. To do herons, we also need to know our S, that semi-perimeter. What's our semi-perimeter going to be? The 10.65. That's when we need to take our 21.3, or you can add up A plus B plus C, and divide it by 2.
And semi-perimeter is our big S, right?
Semi-perimeter is the S in the formula. Yeah. Sorry, my brain just was like not processing the words correctly. So we can do this using herons. We could also use the 1/2 base times height thing because we know two of the sides and the angle on an equilateral triangle is always 60 degrees because they're always the same. So you could use either one for this, but since we're here and we got herons right there, carefully set this one up. This one.
Are we able to just put it as like cube instead of having to?
Because we know we're going to have our S, that 10.65, and we need to take the difference between our 10.65 and the 7.1. We need to do that for A, and then we're going to times that by doing the same thing for B and do the same thing for C. So we're going to have this 10.65 minus 7.1 exactly the same 3 times in a row. And they're all being multiplied, so we can write it like that. Absolutely valid. We could cube it. Totally fine. You could also write it out each time. That's totally fine too. But since it's the exact same side length, we can write it like that. Makes it a little easier to type in the calculator because this one's a little bit decimally. But either way, what are we going to get as our area?
21.8.
Yeah, we should get 21.8, was it 8.3? Feet squared. I'm having a hard time reading my own handwriting, so I'm assuming 8.3 is right, if you guys don't mind about it. My handwriting is absolute messy right there, so I'm assuming 8.3 matches since none of us are freaking out about the decimals. Okay. So even when they don't give us the sides, if they tell us enough about the triangle, we can find it. All right? So I want to do one like the hardest one on the homework. So don't freak out when it comes up on the screen. Okay? I know we're still going to freak out and we're going to whine about it. I know.
It's just too many words.
There's a lot of words. I was gonna say, yeah, it count, we got a picture.
We're probably gonna have to make this.
Do we still have to read it?
I mean, there's pieces in here we need. You don't necessarily need to have all the words there to like write in your notebook, but you probably want to have it so that we can look at stuff. But like on, I'm trying to figure out which question it was. On 8.2, there's a problem like this, and I do believe it does come with a picture. Yeah, 32 has a picture like this, and 34. I don't remember which one's assigned, but 32 and 34 both have pictures. Okay. So, and we wound up with 2 copies now. Look at that. I'm prepared. Okay. So we've got a cruise ship that's going north 50 east from an island to get to its mainland port. We called it M over here. And we know it's 200 miles from the island to the mainland. They're going through some strong currents, so they get pushed off course. And they wind up over here. So their initial bearing is this lower line here. So this guy here, that's our port. And this first angle to the lower line down here, this guy is our north 50 east, 50 degrees. Once they got blown off course, that's when they wound up here at our north 37 east. So they got pushed too far to the north. They didn't go east enough. We also know that the island and the mainland are 200 miles apart. And that they are currently 120 miles from the island. So right now, they're over here, 120. The first thing we are asked to figure out is how far are they from the mainland port? That is a terrible line. I'm going to fix that. Kind of better. We are asked to figure out this piece. What is this distance? That's the guy we want to have right now. So, yeah, we can find this angle because I know that this piece up here is 37 and I know this whole piece is 50. So we can find the difference between them. That is the same color I've already used. Blue. So this angle in here is going to be what? 13 degrees. Now that we know a side, an angle, and a side of this triangle, can we find this other side? I know this side is 120. I know this side is 200. And this angle is the difference between our 50 and our 37 to find this inside-y triangle bit. So then we can use our law of cosines. Our law of cosines was this one, right? A squared equals b squared plus c squared minus 2 bc cosine alpha, that guy. Our law of cosines. Now that I have a side, an angle in between, and a side. So we can find that distance, because our distance squared is going to be our 200 squared. Oh, I just did 200 in the wrong color. That guy's supposed to be green. There we go. And our 120 squared minus 2 times the 200 times the 120 cosine of our 13.
but you want half one.
Because we're not actually asked to find area.
Okay.
Yeah. We're just finding the distance. So this is just doing a homework problem that's a very similar vibe to one that we have. Just trying to get extra practice on this because the distance part is challenging but not impossible. The follow-up question they ask is weird, and I want us to wrap our brain around that. Because our distance is doable. What do we get for our distance here?
87.4.
Helps if I turn the page and actually look at the right problem. We should get about 87.4, 87.35, 87.351, depending on where we round. I'm good with a 87.4 miles. So the ship is currently 87.4, oops, if I write things the right way, miles from the mainland. So if all we were asked was for that distance, we'd be done. But we want to know what bearing the ship needs to be at to get there. So we need to give directions to the boat. They got pushed off course. They need a new bearing to get there. So we need to know what bearing from the boat to get to port. Which means we need to know what angle P is. How could we figure out what angle P is? We have enough information. We could do law of sines to figure out this angle. I'm going to do that one in green. I'm just switching its color just because then it's all the same color as its own side. Because angle P is going opposite of the side of 200, and we know our 13 goes with our 87.4. So we can use law of sines to find angle P. We'll set that up as, bless you, our sine of angle P over our 200 is going to equal our sine of 13 degrees over the opposite of 13 is our 87.4. So we can figure out the measure of angle P. What is the measure of angle P going to be? We should get 31 degrees. Does that make sense logically right there? For that to be an acute angle at 31 degrees? Because what other option is it going to have?
149.
Yeah, because this should not be an acute angle right here. They did not go that far off course. So our obtuse angle is going to be what we need here. Because we also have like this kind of stuff. Like we know there's going to be angles inside here that we need to work with. So this is an ambiguous case situation. We wound up with law of sines giving us an acute angle, and we had a side angle side situation. So we got to watch out for that ambiguous case. So this should really be 149 degrees. How does that help us find our bearing here? You could. We could find our last angle, but the last angle is not going to be super helpful because we don't know its bearing to the island so much. So look at the things we have from our island. Do we have anything over here that'll help us? We've got, yeah. Which one is going to match up with an angle at P? This piece right here. We've got our opposite interior angles So this 37 is exactly this 37. Yes, dear? Because our north-south lines, hang on, good.
Why do
Our,
we need to use that 37?
because what's this angle? This angle, if I take away this chunk, gives me that angle. Because these two lines are parallel because they're north-south. If I'm better at drawing lines, it shows up better. Hang on. Because this is north-south. This is north-south. North is north.
Oh, so do we only need like the not blue and green part of angle P? Like, do we
Yes.
only need the half angle?
We need to know what that angle is.
Oh, okay.
That's the piece I need for my bearing. What piece do we get for that pink angle? We get 112. So we could go south 112 east. I'll take it. But it's not super great because if I go 112 degrees to the south, I'm up here. What would this be off of the north?
I ain't gonna lie.
If we go, okay. You're almost there. We're almost there. Because we just said they're going to go south 112 east, right? North south. East west. Yes? Sneaking behind the board so y'all can see a little bit better.
Yeah.
If I go 112 from south to the east,
Oh, it'd be way.
90 degrees, 112. That's where we're headed, right? This is 112 degrees. Yes? See that? Which one's closer, north or south? To my bearing. North. What's this angle?
The 37.
Straight line, 112. 68 plus 112 gives us 180, yes? So I could write this bearing as south 112 east, or I could go from the north and go 68 to the east. It's, I would accept both, because these are weird.
Where'd you get the 112?
Our 112 came from our 149 minus the 37 to find this little pink chunk right here. Because we just want this little pink chunk. It's just that the boat actually didn't go past the mainland, so they still need to go north. So on this picture, the boat is actually still south of the mainland. They still need to go north more. They didn't go too far north. They just got a lot closer. So with the bearings, we would ideally like to have an acute angle. We should not have an obtuse on a bearing. I'll take it because these are weird and we haven't had a ton of practice with bearings. So I'll take it if we do everything else but that part of it. But just for like 100% correctness, it should be an acute angle on a bearing. Okay. So that's why I wanted to practice one, because there's one like this on the homework and they're gross. They're gross and unpleasant.
It's really just the second part.
It's really the second part. It's really the second part that's the super grossiest. I know. That's why I wanted to do that part. Okay, so it's all about finding that angle between our north-south and where we want to go.